Hey friends, we're on lesson 112. 112, so pull that one out and we'll get started. The first direction says draw a 2.5 inch line segment. Now don't forget, while I'm doing this, you should have a pencil in your hand to be on side A, taking the same notes that I'm taking, writing down the same things that I write. Here's 2.5 inches. And the next one says draw a line segment 1/2 inch longer. So here's 2.5 inches, and if we go another 1/2 inch, we get to 3 inches. Number 1 says John and his sister planted bean seeds. When John's plant was 30 centimeters tall, his sister's plant was 22 centimeters tall. How much taller was John's plant? So we have this little diagram. We put the bigger one, the larger number here, we put the smaller number here, and the smaller number plus the difference equals the bigger number. So the bigger number is 30 centimeters. The smaller number that we know is 22 centimeters. Centimeters. And we need to figure out the difference. Difference is another word that means subtract. And so we're going to subtract 30, take away 22, and we're going to get this. Another way to think of it is 22 plus this equals 30. 30 take away 22 equals... Now these are close enough we can count up. So 22, 23, 24, 25, 26, 27, 28, 29, 30, 8. So the answer we need to put a label on. The answer is 8 centimeters. Number 2, the cost of the eraser is 73 cents. How much change will you receive from $1? So we need to figure out what $1 or 100 cents take away 73 cents is, right? So we can do counting up, or we could do subtraction like this with borrowing. Either way should get you the same answer. So you can use whatever works for you. Now, the other thing to notice is I changed this to 100 instead of 1.00. I could do 100 cents minus 73 cents because 100 cents is the same as $1. Or I could do 1.00, but then I have to put a decimal point also in front of the 73. So let's do it this way, and then we'll do the count up method. So we go all the way over to this neighbor, borrow 1, give it to the neighbor, borrow 1, give it to the neighbor. I should have done that on scratch paper. I'm sure that's hard to see. 10 take away 3 is 7. 9 take away 7 is 2, and that is 0 over there. So our answer that way is 27 cents, or you could do 0.27 and write 27 cents that way. Now the count up method goes from 73 to 100 again. So we count how many jumps to 80. So 73, 74, 75, 76, 77, 78, 79, 80. 7. There's 7 jumps there. And then we can go 90, 100. So there's 20 jumps to get from 80 to 100, right? 20 plus 7 is 27. So you should get the same answer either way. However you need to think about it is fine. When you start getting used to this concept and figuring out change for $1 and things like that, this is the way you'll be thinking about it. You'll be thinking how many jumps to get to the next 10, and then how many 10s to get to 100. Fill in the numbers on the number line. Where is each arrow pointing? So Now we've got an interesting position because the zero's in the middle and we're going to start using negative numbers, which I don't think we've done very much in the past. So let's do the positive numbers first. This is the number line that we're used to seeing, right? 0 and up. And we're going to 5 here, so I can tell we're counting by ones. Okay? So since we're counting by ones on this side, that means we're doing the same thing down here because a number line can't change partway through. We have to count by the same thing the whole way through. So now we're going to do -1, -2, -3, -4, and then we have -5. So a number line going to the left is exactly like a number line going to the right, except we're counting negative numbers. We're counting the distance from 0 the same way, but we have to do negative on this side. And this is just like negative temperatures. So we get all the way down to the temperature of 0, and then it gets colder and we're at -1, -2, -3, -4. So it's easiest for me to think about this side like temperatures. Okay. Where's each arrow pointing? So let's go to A first. A is pointing to -4. B is pointing to -2. C is pointing to 2, and D is pointing to 3. Manuel collects old coins. How many years old is each of these coins? So I don't know if you can see, but I can see that this one, actually I'm gonna get, sorry about that, I bumped it. I'm gonna get scratch paper out, and I misplaced my graph paper, so we just have line paper. And if you run out of graph paper, or you misplace yours at your house, use lined paper, just regular notebook paper, and turn it sideways, and then you'll still have the same columns. It works just the same way, and this is the way I prefer to do it when I don't have any. The number on that coin is 1963. It's even hard for me to see, but I'm pretty sure that's what it says. 1963. The year now is 2020, so we need to do some borrowing. So, go to the neighbor, borrow 1, bring it back home. 10 minus 3 is 7. Bigger bottom, gotta borrow again. Can't go to this neighbor, gotta go to this one. Borrow 1, give it to the neighbor. Borrow 1, give it to the neighbor. So we have 11, take away 6 here. That's 5. 9, take away 9 is 0. 1, take away 1 is 0. So that coin is 57 years old. And this one, I don't know if you can see, says 1972. So we're going to do the same things. This is the year now, 1972, and we're going to figure out the difference. Bigger bottom, got to borrow. Go to the neighbor, borrow 1, bring it back home. 10 take away 2 is 8. Bigger bottom, got to borrow, go all the way to this neighbor, borrow 1, give to the neighbor, borrow 1, give to the neighbor. 11 take away 7 is 4, and then 9 take away 9 is 0, 1 take away 1 is 0. So this one is 48 years old. Okay. Remember yesterday, if a number ends in a 0, we can just tack that 0 on the end of whatever 8 times 5 is. So 8 times 5 is 40, and then we put that 0 on the end. Same thing here. We have 6 times 9 with 2 zeros afterward. 6 times 9, let's do the sixes trick. 1, 2, 3, 4, 5, 6. So I put that one down. Is 54. 54, and then we have 2 zeros to put after it. Again, 4 times 7, we can double. Double 7 is 14. 14 plus 14 is 28, and this time we have 3 zeros to put after it. And that means on both of these we have to put commas if there's more than 3 numbers. So we go 1, 2, 3, comma. On this one we go 1, 2, 3, comma. Number 6. Find the amount of money in each pocket, and then we're going to talk about which one has the least. So A has 2 quarters, so we have 25 and 25. 3 dimes, 10, 10, 10, and 5 pennies, 1, 2, 3, 4, 5. And you don't have to do all these steps, but sometimes it helps to make sure that you get to a right answer when you're not doing things in your head. So if you already know that 2 quarters equals 50 cents, you could just write 50, and that 3 dimes equals 30, and that 5 pennies equals 5. You could always just set that problem up first. 5 plus 3 is 8. So we have 85 cents here. B, we have 3 quarters. Do you remember how to count by quarters or by 25s? 25, 50, 75, 100. So if I have 3 quarters, it goes 25, 50, 75. 75. 2 nickels, 2 fives is 10, and 10 pennies is another 10. Add them up. Now, this is a good reason to use the paper sideways. Make sure you get things in the right columns. 5 in the ones column, 9 in the tens column. 95 cents. Let's do this one right here. 6 dimes is 60 cents, 6 tens. 3 nickels is 5, 5, 5. That's 15. And 15 pennies is another 15. So 5 and 5, we're adding them up. 0, 1 goes up. 6, 7, 8, 9. This one has 90 cents. So back to the question. The question was, which pocket has the least amount of money? So which number is the smallest? 85, right? So that was pocket A. Okay, last ones. Now I see an equal sign in the middle, so that means we have to balance them, right? And I see an equal sign in the middle of this one. We have to balance that one too. So 9 plus 9 plus 9 plus 9. That's 9 times 4. 4 times 9, right? So let's do our trick. 1, 2, 3, 4. Putting that one down. And I have 3 over here. And I have 6 over here. 3, 6, 36. So we have 36 equals, actually I could just write it on here. 36 equals 4 times something. Oh, well, we didn't really even need to figure this out. It's 4 times what? 9. Over here, square root of 10. Remember how to do square roots? A number times itself. So, I'm sorry, square root of 100 is 10 plus square root of 64. Get your multiplication chart out if you're unsure of them on your side. So 10 plus 8 is 18 equals 2 times something. 2 times what equals 18? 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. 9 for both of them. That's the whole thing. Do a little facts practice also, and hand in your scratch work for your side B, and I'll talk to you soon.